Hey all, I hope you're all doing great. It's finally warming up here after a very long winter with the newborn, and I'm beyond thrilled to go outside without 3 layers of coats. During our last video, we talked about what AWS STS is and why we do it, namely that it lets us assume a different IAM role, potentially in a different AWS account or region. Now that we have the foundation down, we're going to go do it. I find that real-world experience helps me the best, so let's get some real-world experience together now. First, let's look at our AWS console and the EC2 instance and the roles and policies that are in place today. I'll also publish all of the Terraform used to deploy this EC2 instance and all these roles, so you can build this in your own account and play as well. Let's jump into the EC2 panel. Here's an EC2 instance I've created and assigned an IAM role. You can see the IAM role there in the center if we scroll down a little. Let's click on that IAM role to view its properties. Okay, here's the IAM role. This role exists as a separate resource from the EC2 instance. Let's scroll down a little and expand the permissions policy to see what we permit the host to do. Okay, we can see in that JSON policy that we permit only using the STS assume role action on a single resource, another role, and nothing else. This IAM role is pretty safe. It can't natively do anything, even to itself. Let's check out the role that we're allowed to assume. Let's copy the name and then go to roles on the left and then search for that name. Let's scroll down a little and expand the permissions policy. Oh, wow. This role has deity permissions, which means it can do any action against any resource in the account. This is really broad. It's not a best practice. You should be limiting even your CI/CD builders to some limit, but it's a common pattern for, say, a Terraform builder, which is exactly what we're going to demo here. Let's scroll up a little and check the trust relationship tab for this deity assumed role. The trust relationship is STS assume related, and it says who's trusted to assume the role. Since this is a deity do anything role, we have this trust policy really limited. It can only be assumed from a single IAM role, the one we have hard assigned to the EC2 instance we created. But that's enough theory, huh? Let's get to the terminal and do some cool stuff. Okay, see this terminal? We're SSH'd into the EC2 instance that we were just looking at. First, let's install JQ or JavaScript Query, which is an open source tool that will help us parse the JSON responses that AWS will send to us for the first couple of commands that we'll run. Then let's install Terraform. First, we're going to do everything using the AWS CLI, and then I'll show you how easy Terraform makes this for us. Let's wget the most recent Terraform, unzip it, drop it into our path. Then we want to set a few variables we use in our commands. These are mostly so you can run these commands in any region worldwide, and it'll work. How about that? Next, let's look at our current identity. The AWS STS get caller identity command shows us that we are currently using the permissions of the assigned role, the one that we statically assigned to our host, which makes sense. That's the first role that we looked at. It doesn't have any special permissions at all. Can't do anything except assume a role. But let's test that theory. I have an AWS command to describe all the EC2 instances in this region. And you can see it gives us an unauthorized error, which makes sense. We don't have any rights at all, so we get blocked. But we do have access to a deity role that can do anything. So let's look at how we'd utilize it. Let's clear the screen and check out the assume command. There's a lot going on here, but let's check out each section. First, our command. We say use the AWS command line and STS assume role command. We tell it the exact ARN of the deity role we want to assume, and we give it a role session name. That session name is beyond the scope of what we're doing today, but it'll let you assume several different roles at once and switch between them and do different things. Totally okay if that doesn't make sense. That's beyond us today. Then let's check out the JSON packed response. We have a credentials block with a secret access key, a token, and an access key ID. This response, rather than a permission denied error, means the STS service is granting us the rights to assume the target role, but it doesn't do it for us. We need to export the right variables into our terminal for it to work. We could copy and paste each of these values we got into the right variables, but there is an uber command that I found on the internet that will work for this. You can type it in if you're very brave, but I'll include it in the GitHub repo for easy copy and paste. This command runs that same command that we just looked at and talked about, but it traps the JSON response and parses it with JQ to export all the right values in the right place. This immediately elevates our terminal commands to use the new role. Let's check me on that. Again, let's run the getCallerIdentity command to see what role we're using for our commands. And you can see we're now operating as the deity role, the one with unfettered ** permissions to this account. Let's run that same command that we ran earlier that gave us an error message, and we can see that it worked. Yay! The response isn't important to us, rather it's that we were able to do something with this new role that was blocked by our assigned role. To revert to our assigned role instead of the assumed deity role that we're using, you can curl the EC2 metadata to get the creds for our implicit IAM user. Here's what that looks like. You'll see the same access key, secret access key, and token just like before. Let's run another uber command to do the same thing. Query that node, then map the response using JQ to the local terminal variables. Let's check our identity again, and we can see we're back to the assigned role. That was a lot of commands, right? And you can certainly use these commands to do assuming, but most tools you'll find in the wild make it a lot easier. For instance, Terraform. Let's run some Terraform and see how easy they make it. Here's a Terraform configuration in Visual Studio Code. Check out the AWS provider block on line 13 and specifically the assume role command on line 15. You are now an expert at what that does. It's assuming a role as part of any resource built with this provider. Afterwards, when Terraform's completed its run, it releases the role, and the host goes back to the implicit role. But don't listen to me, we can test this. We have a data call to find out current identity, which is a whole bunch of stuff. Region, account number, but also the IAM user doing all the work. And we have an output that will paste the ARN of the IAM role running this command. So let's switch over to our terminal and check out our Terraform command. I already have this Terraform file copied to the directory, so let's run it with auto approval. There are no changes because there's no resources in our Terraform config, nothing to track, but it does output the IAM user who ran the Terraform, and it's our assumed deity role. That's pretty cool, huh? Terraform does all of this for you. Whew. That was a journey, wasn't it? But that's it. Now you understand IAM roles, trust policies, and how to use the AWS STS command to assume and release roles, and how to use Terraform to do the same thing. And all in under 10 minutes. That's pretty cool. Thanks all. Until next time.